Starting the stream. Oh dear. Well, it's been a while, but I'm back at it apparently. So yeah, let's do a thing. I feel like I was better at this in the past, maybe. I guess usually it's because I have more of a plan of what I'm doing rather than just trying to do something. It should really be on my Desktop Adventures channel, but yeah, it is what it is. I have all sorts to talk about though. It's just whether or not I will or not, because I have a weird thing of being like, yo, I'm talkative, I'll do a stream, and then just like not talking at all. I've already gotten over that by talking a bit now anyway. I mean, I haven't said much valuable, but I'm better than no talking, I think. So how long to go for? I guess start with like an hour 40, and if it's dumb, then I'll reduce it, and if it's like, yo, this is kind of cool, kind of increase it. Okay. You know, it's funny, I saw a video by Michael Stevens, like creator of Vsauce channel, and he was like saying about how people tend to say like more personal things, or like share more personal details with robots than with other people. And when I saw it, I was like, nah, it could never be me. That is just not a thing I would do. And then I realized streaming's a thing. But sometimes on streams I'll be like able to say things that's like more what I'm feeling than if I was talking to a person. I was like, gosh dang it. I guess Vsauce was right, so so yeah. That's the thing. I can't remember why I said any of that, but it doesn't matter, I filled the space, which is what I needed to do. Alright. Is my drawing tablet gonna work today? Oh my goodness, I think it is. Let's start the day with, oh, it's lagging though. Why is my computer lagging? There's like no applications open. Save memory there. I don't know how else I'm gonna save more memory though. That's very not poggers. There shouldn't be that much memory. Oh, maybe my computer's just getting old. I should probably get a new one at some point. Oh yeah, the drawing tablet's fine, it's just the software's slow. I don't know how to fix that. You know, it's quick enough. Oh, it's kind of, oh well, it's okay. Could be worse. I guess in a bit I can try closing the software, opening it, because I'm using Paintbrush or whatever. Okay, so unlike usual, because I'm more awake than usual somehow. Oh, I'm going to square off this bit because that's where the webcam is. Because sometimes I write where the webcam is, so if I square it off, probably can't see it because my webcam's in the way. Then I'll remember not to write there. So yeah. Okay, and everything with the stream's going alright, right? Check the stream health. Yeah, that's all good. Okay, so what to do today? So basically, I moved educational institutions, went to the same place for like a whole of like last year. I was meant to stay another year, but then things happened, things went down. So yeah, I was going to talk about the new place a bit, but maybe I don't care enough. I care a bit. Also, I can't tell whether I just have a crippling cold or whether I'm just really down. It's one of the two. I can't figure out which at the moment, but if I figure out, that would be great. Because if it's a cold, then I know I just need to sleep more and be fine. But if it's a down, then it's like a bit harder to fix, I guess. Maybe, I don't know. Maybe they're both just equally hard to fix. How do you fix a down? Because a high doesn't work either. Well, it does, but like highs aren't sustainable. Like if you're in emotion, it's like we learn about this in economics as well. Actually, it's like if your baseline emotion's like this, and if we'll do it a different color. Yum. Oh yeah, you signed up for a philosophy video today, by the way, guys. If it says study, it's like interchangeable with philosophy on my channel. But that's the thing. I should probably talk about computer science this channel more. I've done a lot of computer science in the past though, and honestly, just because my main is computer science stuff doesn't mean everything has to be computer science here. So we're doing philosophy. Oh man, what a moment. So then if we have like input, like emotional input, whatever, like this, then you can have like a peak, but highs don't tend to be very sustainable. and they tend to like disappear as quickly as they arrive. So in this situation, we'll have black being what would happen without the high, but with the high, like you'll be pulled up. No, that's not right. You'll be pulled up a bit, so when the high happens, or even in anticipation of the high, you'll be like, yo, and then the high will like help you go up. But the thing is, when it's over, it's like, wait, hold on a second, that's just death. Wait, no. Oh, I got rid of all of it. Pain. Ah! Alright, put that over there, increase that. I know no one cares about this, I don't know why I'm spending so long on it, but you know what? Gotta start with this idea. The thing is, once I'm like, I'm gonna go through this idea, I'm like, I have to finish it, even if it's a dead idea. I don't know if that's good or not for comedy. Need to look into that. Yeah, it's like it's pretty, and sometimes you can even go below your baseline. So, and now we're worse off than we were before. So fixing low. Wait, let's draw a happy face where happiness, like standard levels of not down are, say here. So it's clearly this black is a low. I'm gonna put it a bit lower because I feel like it. Yeah, I'll put that as a happy face. So it's not so. Wow, that's a very happy face. There we go. I'm sure there's some sort of psychology about drawing smiley faces makes you feel happier just drawing them. I don't know. So the baseline would be like here. So clearly this black is quite a down. So even with this high that we've tried to construct, the green is the pathway where you do that. You can end up having situations be worse than if you had done nothing. So you've ended up being more down than before. So fixing downs is probably harder than fixing a cold, but I don't know. I don't study psychology, so could be entirely wrong. It's just theoretical stuff and whatnot. Okay, it's time for MAT reflection, MAT training. So there's this scary math submissions test thing, and there are 7 topics. The 7th one we haven't done yet, but it's a bit different in like delivery and stuff. So those are the different areas. I was going to copy them out, but like that's dumb. So I might just copy paste that because that seems like a better idea. Yeah, I don't know how long it will take. Yeah, I don't really care. Actually, I kind of want that as well. Lovely. Oh, I wish I had some stream chat. I don't think I do I? Nope. Okay. It's one of those things where it's like, yo, I have to ask myself questions. What made me think this is quick? This is more efficient than me studying without streaming. Maybe it is more efficient. Maybe I'm that inefficient using pen and paper. But streaming, even with things like this that takes more time than it should, it's still more efficient. I don't know. H. Okay. No, you know what, this, I don't know why I was complaining about how long it was taking. This is fine. This is fine. So we go, all copy, dump it on here. Oh yeah, that is gamer. That is absolutely phenomenal. Amazing. I'm going to write numbers 1 to 6 here because I want to. No, I don't. I'll write x0. Not x0, x with a circle. And state x is at the cert. This is so extra. Why am I like this? This is what mathematics does to you. Mathematics, I don't know what other people think it is, but honestly all it is being extra about the smallest technical detail ever, and then creating an entire textbook or chapter out of it. But it's useful because you have to be accurate to be useful, not to be useful, to fix systems that require accuracy. You have to get on the same level of accuracy. So you have to be extra about everything. Yeah, that makes a lot of sense. Curve sketching. Okay, so I guess I'll just like go through them and say a bit about each one. In this section of 6 of the stuff we did, there's obviously questions like sketch the graph of y equals. I don't know why I'm doing this, by the way. I'm just talking about training for MAT, the scary university maths admissions test. done by a bunch of universities here in the UK, like Warwick, Imperial, Oxford, Birmingham. I think, no, not Birmingham, Manchester, I think, maybe. They require the MAT to mirror those kind of things. So he asked like to sketch that. I could maybe do that now, but I don't know if I can be bothered. And that's basically the whole of this section. And you sort of focus on lines of symmetry and like what the graph tends towards. This isn't going to make sense unless I do something. No, you know what? Unfortunately, I'm going to do a quick bit. We're going to use radians. No, I'm not going to use radians because radians just, you like lose so many people just using radians. It's just not worth it. Like audience members, because like you don't learn radians when you learn angles to begin with. Because degrees are just, I don't know why. No, because that means you have to use pi all the time, and you don't want to be using pi all the time, because like figuring out what's going on with pi is just no fun. So if you use degrees, you can avoid it. With radians, just as a side note, my entire videos are just side notes though, so you know. So that would be 360 degrees, but that would also be 2 pi radians. In the same way with angles, you'll tend to take the full turn and divide it for other angles. For example, a quarter turn would be 360 divided by 490. You do that with radians too, so a quarter turn would be 2 pi over 4 radians, which is just pi over 2 radians. So for like all your common angles, you'll be using pi all the time in radians. And if pi is just the kind of thing that's kind of tricky because it's not a quotient, so trying to think about what it is like pain. So like if you can avoid using it as much as you can, it's kind of a good idea. So it's kind of nice that with degrees you don't have to use pi all the time for measuring angles. So yeah, so let's imagine the graph. Yeah, we're using degrees because radian moment. I mean, I've just explained radians, 2 pi, so I could use radians, but I don't know. For me, trigonometry, like it just feels better drawing the sine graph in terms of radians, but I feel like they actually introduce it with degrees. So actually this is probably way too small to be seen, isn't it, this list? Oh well, I probably should care about that more, but I just can't be bothered. It's a very can't be bothered moment. In case you can tell, I'm in like a huge weird mood of weirdness at the moment. I don't know why. So I'm pretty much streaming out of, yo, streaming would be fun. I haven't streamed in a while. I have just enough energy. I have lots of energy for streaming. I just don't know if the stream's any good. Only time will tell. Alright, so we're saying the graph y equals 1 over sine x exists. We're going to draw it, and we're going to set a domain of values x is valid for. So yeah, x is valid for, we're going to do it in degrees, because degrees moment as previously philosophized over 0 degrees to part of me wants to start from, maybe better if it was cosine. Flip, we're doing cosine. Because I'm a crazy boy. Would it be bad? Yeah, it would. Yeah, it would. You know, this is a pretty good way of looking at the, it's a pretty good summation of the curve sketching topic in the problem solving matters MAT training course thing. I know it's just going to be like me just saying words, so I'll stop now. 0 to 90, or in radians, 0 to pi over 2 radians, but we use degrees. So what does this graph look like? Well, we know it's only going to be values 0 to 90, and if we look at the cos graph from 0 to 90, then if you recall how cosine works, I'm not going to go into why graph looks like this, but it like curves up and down, and for the first 0 to 90 degrees this is the graph. So as you can see, because the value is decreasing from 1 to 0, our graph of 1 divided by cosine, as you divide by a value that's approaching, so this is in the form 1 over h, whereas the angle x increases towards 90, as x approaches 90 degrees, as you can see the graph dips down, and h approaches h approaches 0, but it's 1 over h, so as h approaches 0, our output 1 over h. Oh yes, Kayoshi has responded on the Discord. Maybe that'll mean I'll get another viewer. That would be, well, not another viewer, a viewer. That'd be hype. If not, that's fine. Yo, Kayoshi's just finding a way to get on internet. Oh my goodness, that'd be hype. As h approaches 0, y approaches positive infinity. Because h is approaching from positive number, positive 1. So as it approaches 0 from the positives, this will approach positive infinity. So we can, like, this is all about curve sketching, not curve perfectly plotting. So you want like the rough shape of it. So we know at 1 cosine is x is 1, cosine is 1, 1 over 1 is 1. So we know it'll start here, and we know as x increases, the value is going to keep approaching infinity. So it means you can deduce that the graph is going to look like this, going up and up to infinity. That's a terrible curve. Can I make it look nice? Oh yeah, that's a pretty pog curve. It'll like keep going up and up like that. There we go. That's one of the key things in curve sketching, is looking for what we call asymptotes, where the function starts growing uncontrollably towards infinity. And that often happens when you stack like quotients, cosine, sorry, not cosine, trigonometric functions and all that fun stuff together. Or you can like dump polynomials in places as well, and all that fun stuff. Especially with I think with the trigonometric function, it's particularly common because trigonometric functions go up and down through 0. And when they hit 0, if they're in the denominator of a quotient like here, it means you end up with asymptotic behavior like that. And this is at x equals 90 degrees. Alright, this is pretty fun actually. I don't know how fun any of this would be. I don't know how productive it would be either. I'm going to reflect on how productive it was afterwards. It feels marginally productive. I just never know. I mean, it's better than nothing. It's better than sitting down looking at a page of things that could be done. I mean, like, which of these things am I going to do? So I guess streaming's helped. What did we do in geometry, coordinate geometry? I think that's one of the modules I just like fully, just like hardly understood what was going on at all. That's what module 2 is. Why have I written a 2 here? Did I just do that? I don't know. I mean, I could talk about coordinate geometry. That I doubt that's what we did in the lecture thing. Oh, geometry, we looked at extremes. I'll create another one for this. I wish I could like create some problems as well, but I don't know if I remember any of the problems. I guess this is what it's about though, recall, remembering what the problems were like. I remember what the problems were like for curve sketching, but that's kind of easier to imagine because you just choose any function, really. Like just dumping sine and cosine together and boom, you've got yourself a problem that's interesting and decent. Yeah, you want to look at extremes. I do remember one with like folding a corner, but I don't remember it enough, I think, to do it. So, And all I remember is look at extremes, so that's all I'm going to put on. There we go. Epic. Great recall. I just remember doing like some weird like problem solving stuff with like linear algebra, but not saying linear algebra. But again, like the whole thing with the MAT train / problem solving matters is not about the content, but about the problem solving. So there's no point me going into linear algebra as much as I want to. But calculus, we pretty much just looked at, number 3 is calculus, by the way. Maybe I should rewrite the topics so that you can see them, because it's kind of important for what's going on here. None of this is that productive, though. I wish I had problems I could just solve, but unless it's a past MAT paper question, I can't really show it because they were created by someone who, like, you paid to get the problems, so I can't just reuse them, unfortunately, on the stream. Well, I could, but I'm not really meant to, I think. Should probably just ask. Is there anything else worthwhile here? I don't know. Logarithms were mostly just about make sure you know the basics. I don't know if you can see this list. I wish you can. If not, it's going to be a big problem. Sequence topic was cool. Just did that. Yeah, no, maybe I should just create my own problems for it and then do those on stream. It's just so much effort to make maths problems. And they also need to be ones that I don't know the answer to. Like, sometimes you can create maths problems where you don't know the answer to it. Like, for example, I couldn't tell you, like, I can quickly, what am I doing? I can quickly write. This stream is such gobbledygook, but you know what it is what it is. That's my happiness curve. Yeah, like I can write y equals sine cosine x. Like the question can be sketch this graph and have no idea what this graph looks like and therefore not know what the answer is. So it's definitely possible to make questions you don't know the answers to, but I feel like sometimes creating the question means you also like know how to solve it immediately. So I'll think about that more. All right, well that was reflection on MAT training stuff. The other thing, I'm just going to write on my to-do list. This is big weirdness. But that's my streams in a nutshell. I'm going to get a timer on Google so I can see it. Do-do-do-do. Mm-hmm. 1 hour 17 minute timer. I don't know why it's doing that. There we go. Now I can see the seconds of life draining out of existence. What am I saying? I'm sure plenty of literature enthusiasts have strong opinions on time and its significance. I don't know if I do. And physicists do as well, I think. Well, it depends if you're really theoretical and like really passionate about the philosophy of things. I'd love to like hear or know about like a theoretical physicist who just has no interest in philosophy. I don't know if it's possible or not. Maybe you need it to motivate you for all the calculus like pain you have to go through as a theoretical physicist. Alright, going up from 11 to bigger than 11 probably. I mean, part of me is like, no wonder I couldn't do any studies not doing this, because even with streaming I can't like bring myself to do much. I can bring myself to do more. So I guess just my motivation levels are low. Either just because they are, or because my cold's just killing me, if I have a cold. And my nose is fine. I haven't really been coughing too much, but maybe the cold's still just like sapping my energy. I don't know. Voice sounds kind of dead, so maybe. It's kind of like one of those moments where it's like, you know, you shouldn't really be making videos, but you kind of want to anyway. Kind of like with Technoblade, how he got cancer recently. He's like, I'm still going to keep making videos. It makes sense, but it's just funny. I could make that smaller if I wanted to, which I kind of do. Oh, you can't see that. You could see if I put it there. Okay, stuff doing, yes, please, thanks. Oh, catching up on a Maths Volume 2 decision is a very big one. It'd be quite fun. Maths Volume 1 recap. Volume 1 Volume 1 Year 1 Stats Recap. Maths Volume 1. No, Maths Year 1 Mechanic. Almost Physics recap. Maths Volume 1 Year 2 Current Pure that I get recap. I could do that. I almost did that and then I didn't. Part of me wants to list all the things just to make sure. It's also this thing where I need to figure out switching Maths Volume 2 course disconnect for pure. None of this is that exciting. Especially listing it is not good entertainment content, or just content. Or I guess content is entertaining by sort of it's set up. Streaming's hard, but it's okay. It's all part of it. Oh yeah, I should talk about switching educational institution more. New Place is wild, man. It's pretty fun, but they do like a talent show every year, and I was like, that's a good idea. I was gonna like say something like that would be cool. Just so many events. They do like big events that are just like the coolest thing ever. Like apparently done like movie nights and stuff. And I'm like, yo, that sounds like a great idea. Why didn't they do that at the previous place I was at? I should kind of feedback. I wish I could. I can't just go back and visit. Well, maybe. I don't think I'm allowed to just like visit the old place from time to time. I thought it'd be cool, but it's what it is. Yeah, let's tackle some of this. But yeah, no, so there's a talent show at the place I'm at. The educational institution. I need a better word for that. I mean, I know the better word school, but like, it's kind of like with universities. No one calls them schools, so it's kind of like, need a word that's not educational institution because that's too long. It's not school because it's untrendy, but I don't think anyone's had an idea for it yet. So yeah, it's what it is. All right, gamers. So here's the list of things to be learned. It's just a topic called algorithms. Bro, this isn't computer science, it's maths. What is this? No, this is a great idea. Learning these things on the stream. I don't know how it's gonna go. I'm thinking of using a combination of like searching things online on a that you guys can see on my monitor and using this textbook I have somewhere. Where's the textbook? I can show you the cover of the textbook, but I probably can't show what's in the textbook because of plagiarism or something. Like I can't show you paid for textbook content. Sad times. Where is it? Somewhere here. Oh yeah, I see it. The most intimidating textbook you'll ever see. Here it is. Oh, let's see if you can see it. Have a look at my stream preview. Oh yeah, you can definitely see it. Is it the right way around as well? Oh, it is. It doesn't invert it. This is a good camera. Some webcams invert it and it's so annoying. Yeah. This, where does it even say decision on it? Oh, discrete. You can kind of see here. Oh, the delay is intense. There it is. I'm trying to point at it, but the delay is too intense. I should just look at what I'm pointing. Yeah. Fail. It's taking way too long. Yeah, anyway, there it says decision, or discrete, sorry. But yeah, no, what's intimidating in the textbook, I can't show you too much like inside. What's not intimidating about it isn't the front. It's, well, the front's a bit intimidating because it's all black and white and like scary pattern stuff, but all the textbook like insides are all in black and white too. So like newer textbooks, they tend to put colors in there, like to keep it more like, I don't know, not intimidating. But this is all black and white inside, so it feels very scary. Anywho, I'm going to use it to try and learn about algorithms within maths. That's ambitious. Okay. Got the contents page here. Going to copy out. That's the thing to do. Maybe read things, try and copy it out. Find some online resources. I don't know. I had this idea a bit ago in the summer holidays that just went by. I was going to try and like learn all the rest of the courses I was doing because I was that fed up of going in to learn them like in school. But then I just didn't have the like willpower or heart to do so. And things got kind of stressful, so like with other things, so I didn't have as much time to just like learn. And I was trying to like do other YouTube things. They failed as well, by the way. But I can do it now. Trying to learn live on stream is a thing. Yo, Kayoshi, I missed your messages. No. What's popping? I don't know how late I was. Further maths, yeah. we're doing maths wasn't enough, so we're studying further maths. Its own new field of study. Oh, I still have Kayoshi as a viewer. That's incredible, considering how slow I was to react. All right, yeah, Kayoshi. Let me tell you about this textbook. It's wild, man. It's a bit. I feel like it's outdated. Hello. I feel like it's outdated. Because it's like teaching algorithms in a maths textbook. My brain is like exploding. So these are the topics it's teaching apparently. I have a bit of a computer science education from last year. I spent half the year on a 2-year course. So maybe this will be easy, but maybe it won't. Maybe it will do things like in such a dumb way that like, so these are the 5 sections it has. It splits the chapters into sections. I'm pretty certain I know the answer to the first question, but I'm going to see what the textbook says. Yeah, algorithms POG. That's what I'm thinking. Except I'm also intimidated by it. Like, this is a whole 7th of a 2-year course textbook on decision mathematics, which is supposed to take up a 6th of the whole maths course that you do, like a wider maths course that has decision, statistics, and pure. So that's a lot of content on algorithms in a maths course. It's kind of scary. Pretty intimidated by it. Okay, to begin with, what is an algorithm? Should I just read it out of the book? I guess I have to just read it. Oh yeah, I was thinking about this, like how I'd structure this, and I thought I'd like read it, but like not out loud in my head with like some music, and then like report back on what's going on. This is intense. Oh my goodness. Maybe I'll just write. No, I'll do the music thing. Oh, by the way, Kaish, this is kind of a scary looking list, but this is like the things I could do. It's all maths. I could do maths or chemistry. If you prefer maths or chemistry, please say, because I can't choose how to prioritize my studies. So asking random people on the internet seems like a good idea. You think that? It's not too much text. How many pages is it actually? Wait, let me tell you how many pages it is, Kaish. This is gonna be funny. Oh man. It's a whole like 10 pages on what an algorithm is in a mathematics textbook. Wild. I don't know. You don't really like chemistry? Hey, that sounds like a challenge that I'm gonna try and. Oh, what? You're excited about not having chemistry classes? Shall I ruin your entire? But you already know maths. At least with chemistry, I could teach you something new. Oh, so much for not having a cough. With the maths, you'll like know of it, even with this. Or maybe not, though. This is so unique that a maths textbook's doing an algorithm. It's got some interesting stuff here. I might read a bit and then report back. I'm also doing economics, by the way. Do you want to hear about any of my economics classes so far? If you do, then I can tell you about my sick economics classes. It's not that I don't like chemistry, it's that if I don't do chemistry, I can do more maths and computer science. What a gamer. To be honest. Oh yeah. Oh, it's wild. I might just go into some economics just because this will be good, because everyone I've spoken to so far, like either does economics or like is doing economics at the same rate I am. So it's like usually when I'm talking to people about economics, they already have like a fair bit of understanding, and I'm really interested in like what things aren't or aren't obvious about economics for like someone who doesn't do it. So you know what? This is an opportunity I'm not willing to pass up. We're gonna quickly do some economics. Okay, so to begin, we'll look at how I like to start any field of study, which is to look at what the origin of the word, or the name of the field of study is. So I feel like economics is a pretty exciting one. It actually stands for, the word means home accounts. It was originally created to keep track of how sort of like wealth is distributed within a household. So for example, how much, I don't know if inheritance comes into it, I imagine it does. It's like everything to do with accounting and finance. I don't know if you've ever heard of that, but it's essentially like inheritance. Yeah, first we need to talk about what economics are. Absolutely. We're using a mathematical symbol because, you know, that's how I absorb the world around me. So economics is split into 2 main branches. We have, formally it's split into 2 main branches. For me, I like to split it into 3 branches. So let's do that. We've got hyper microeconomics, my favorite. Like unironically my favorite. I invented this strand though. This is kind of how microeconomics started, but now microeconomics is a lot more rigorous and useful. And even stuff like the stock market, if you've ever heard of that, is studied within microeconomics now. So it's a lot more developed than when it was hyper microeconomics, which we'll talk about because I think it's hilarious, and I'm going to go into that. And then we got macroeconomics. So we can talk about each of the different threes. So me acting like I'm a qualified economist, I've literally had maybe only about 4 to 7 teaching hours of economics. Plus, I've read this like book that's really good, but not even much of that, like 20 pages of the book. So, but I like philosophy, and I like philosophical ideas and trying to take them on board quickly. So maybe I'm a bit qualified. I don't know. I'm going to pretend I am. Making the assumption I'm qualified. This is how economics works. When's hyper macroeconomics? That's basically astrogeology. It's an interesting one. You raise a good question. Or I like to call astrogeography. There's a sick video on it I'm going to recommend just now. I don't know why I didn't think of that. That's usually one of the things I would think of as say. So this is why you stream, kids. You learn things quicker because smart people on the internet will pick you up on things. And Keiosha is definitely one of those smart people on the internet. Yeah, that's this video. Let me search it. I think it's the Kardashev scale. Only death of my throat. It's by Kwartskovev, I think. I don't know how you pronounce it, but Kardashev scale. It's like this video that's like well worth watching. Here it is. You're very tall, actually. Did I call you small? Oh, I'm sorry. Yeah, this video here talks about hyper macroeconomics, which is essentially economics, but on the scale of like galaxies. So yeah, I'm glad you thought of that idea. My life is now being rich. There's now 4 areas of economics, and I've always wanted astrogeography to fit into something else. So the fact I can put it into economics is cool. Okay, this is too ontological. I don't think this is worthwhile. I should go back to the formal economics. Oh, my internet's dead. Have I killed the stream, Pog? Oh well. It was worthwhile to try and get that video open. I'm just going to carry on, hoping that... Wait, where's the drawing tablet gone? There it is. Where's my pen, though? Oh, there it is. Alright, so the difference between the 3 is why is it doing that? Oh, I know why. Because I'm being dumb. Okay, so in a hyper we'll start with microeconomics. So an example of something that would fit into microeconomics is if you were a salesperson and you were trying to sell me a tablet and I was at the shop and I could choose to buy the tablet or not, and you were trying to convince me to buy the tablet. That sort of interaction of either me buying the tablet or not buying the tablet and you trying to convince me to buy it is a microeconomic situation where we look at either one transaction or one market of like all the tablets that are sold or consumed or bought and all that stuff. So that's microeconomics, and that's pretty small scale. So you might be wondering how small scale are we going with hyper? The answer is very. So this is a market, so like all the fish maybe caught, sold, eaten in the UK. Study of that would be microeconomics. Macroeconomics is sort of the exciting stuff that everyone talks about in terms of like governments, news, how much public spending, taxes, all that good stuff. All comes into macro. And accuracy sort of decreases from here to here. So micro, I think you can be a lot more accurate with than macro. Macro is very hard to figure out what's going on accurately because there's so many people and so much going on. Even with micro, there's lots of people involved. So I guess economics as a whole, it's hard to be completely accurate. Or just write fish to help remember what's going on. So we've got fish here. We've got galaxy here. Can I write joined up? Oh my goodness, I can. That is hype. And then here we got nation. Okay. So those are those 3. And then hyper microeconomics is kind of a thing, you know, historically. I thought this myself. I was like, what if we applied the lessons of microeconomics in terms of actually buying things into like just a household or just like a social interaction where there's no currency yet or at all? So, for example, I was sort of thinking about I can tell you about what you've done in an economic sense, Kayoshi. You've created within yourself a deficit of fish consumption, which overall reduces the economy because you are making less sales. So therefore, the fish market is flourishing less. That's my new favorite pastime, by the way. It's someone just saying like the most like normal thing, and me just like economically analyzing it using like all the terminology. It's way too much fun. I've done it so much already, and I think people find it annoying, but it's hilarious. So yeah, you're no, you're not a threat to society. If it was macroeconomics, it would, but this is microeconomics still. So you're only a threat to anyone selling or fishing fish. The rest of society will be fine because you're still buying food. You're probably getting bread or or croissants or whatever instead. So you're still contributing to the national economy. So macroeconomically speaking, you're fine to society. To the fish market, though, yeah, you're definitely a threat. Okay, hyper microeconomics. So an example of that would be like, the way I was thinking about it is like if you're in a house and someone unstacks and reloads the dishwasher. The idea is that by doing that, you're increasing productivity of the house and therefore increasing the local economy of the house is sort of a hyper microeconomics idea. Because there's no currency, like it's hardly a transaction, but oddly enough, the rules of microeconomics oddly still kind of work, even when there's no money involved or currency. So that's what this is. So I'll write house here. And another key thing to understand about I think all four strands, we've created a fourth strand here because Kayoshi is just too intelligent for his own good, pointed out that we should have hyper macroeconomics, which I completely agree with. So what's interesting is even though each of the four areas seems unrelated in terms of how you do it, the maths that we use for all four ends up being pretty similar. Like the way we study a whole nation, we end up doing a similar way to how we'd study just one market, which ends up, in my theory at least, or anyone who believes in the hyper microeconomics, which probably isn't too many people, it still works, even though we've shrunk from the size of a nation to the size of a house. The rough statistical ideas apply throughout, which is a pretty crazy part of economics. I mean, we've never had any reason to use astrogeography or the Kardashev scale as such. It's what they call it formally. But if we did, the idea is it would still follow the same principles as the other three because it seems just to underlie all these different areas. So that's kind of the idea. But as I was saying, you lose accuracy. So the idea is you'd be more accurate here, although maybe that's not the case. But definitely here, you're more accurate in micro than in macro, using the same sort of scales. That took a lot of time to talk about the different areas. Maybe it's worthwhile, I don't know. Do you want to go deeper down the economics rabbit hole, Keishi, or shall I switch back to like maths or chemistry? I don't know if it'd be worth teaching you chemistry. I mean, it'd be great for me just because chemistry, but if it's not going to benefit you at all. I mean, the maths isn't going to benefit you either. You know so much maths, there's nothing I could really teach you don't already know. You don't use money. Interesting. That's literally me as well, to be honest. I think that's maybe why when I start learning about economics, I'm like, this doesn't relate to me, but if I invent hyper microeconomics, then suddenly it'll be relevant, so that's kind of how it stemmed, but I don't know. You want to go deep into the galaxy, the economics galaxy? I mean, I'm not qualified to talk about astrogeography as such, but yeah, but the level of maths I'm doing is like first college year. Like if you look at all the things I'm doing, none of it's that advanced. I don't have the energy to learn it more advanced, so I have to do like that kind of stuff. Basically, I'm not a very good mathematician. I'll be better in the future, hopefully, is the goal. But for now, I'm like not. You don't need to buy anything. I mean, economically speaking, that makes you like a bit of a burden then, because you still have to eat food, you still have to consume things. So, but then you're producing like academic excellence or whatever. So, no energy to learn math. No, that's why I'm streaming, because I was just going to learn maths on my own, but I was like, I'll study maths on my own. I'm not really learning stuff as much as trying to recap things I've already done. Speaking of which, I might go back to being a bit more productive. Oh, the economics is productive. So now that we've covered economics as a whole, roughly speaking, the different areas, you're a virgin, yeah, roast of the century. I don't even know why I said that. I just realized that you're not, by the way. I don't know if you heard me changing my mind on that. But I was realizing, because it's if you consume or produce. If you only consume and never produce, then you are. But then I realized because you're learning stuff, because you're like going to college, or whatever you call it in France, you're actually producing as well. So you're okay, Keiichi. It's just weird that you don't use money, but hey, I guess that happens sometimes. Maybe we should invent a currency for students of like if they study enough, they like gain money that lets them do things. I don't know what I'm saying. So now that we've covered economics as a whole, we can like zoom in on what we've done in class so far. So we've kind of done a bit of like overall structure, kind of like I've done, but a teeny bit more rigorous and formal. But I can't bother to go into it. It wasn't very interesting. And then there's like these 4 lists that we just have to memorize. I know, but someone has to pay for the food place. I'm guessing you get student loans in France, which I'm guessing is how it's paid for, but I could be wrong. So you're using money, but you just don't realize it, is what my proposition is. So you do use money. See, I've sussed you out. So we just looked at 4 lists. Oh, we've looked at supply and demand curves. Supply curves are hard, but demand curves are not too hard, but like will sort of blow your mind a bit. Demand curves are cool. The 4 lists I need to memorize, and I might go into either very soon or further away, or maybe not even this stream. Like I need to recap these 4 lists so I memorize them. But it's so dull that for now we're just going to look at demand curves because they're cool. Oh my goodness, Keiichi, you're about to be blessed by education and demand curves. Oh my goodness, and PPFs are cool too. PPF stands for Production Possibility Frontier, and that's an important phrase. That's like a buzzword in economics, so I'm going to write it down. Production Possibility Frontier, and they're also really cool. You know what, we're going to cover both because I'm making good YouTube content today. Oh, I absolutely love it when I get a view. Thank you so much, Keiichi, even for a bit. Which one do you not know? Oh yeah, no, I know. That's why we're about to go into them. Oh, you're about to have a. Oh, I can even do it with you, Keiichi. We can get data for you. Oh no, we need more people. I can even share. You know, I'll put us as data entries, and then I'll first of all, basically for economics, for analytical economics, usually done in micro, occasionally done in macro, but in macro I don't know much about. In microeconomics, yeah, we're going to go into the demand curve and the PPF. Let me write PPF here. PPFs and production possibility frontiers. They're both mind-numbingly cool. Yeah, so in economics, especially in micro and very analytic economics, I can't really tell you the difference between analytic and empirical yet because I haven't really done enough of each. We've mostly focused on analytic because it seems to be, I don't know why we focused on analytic for now, but we have. What happens in analytic economics, it's kind of like physics. You'll go data, so you collect data. This allows you to create a theory, and then you'll come up with a method, and then you use the method with more data to get like results and stuff. But this is not important, no one cares, but it is important because we're going to get some data now. So Keiichi, I want you to imagine that at your school they sell Kit Kats and you have money. Let's assume that you get 22, oh I need to use euros, don't I? So I can relate to your world. Alright, let's imagine, I don't know what exchange rates are like. A few seconds. Okay. I'll do some more writing. That'll be cool. And then I can recap if you didn't get it. So we're imagining Keiichi, YouTube unlive viewers, or wait for Keiichi to go back. Imagining he gets 24 euros a week and his school canteen sells Kit Kats. That may be a language barrier if they don't have Kit Kats in France, but hopefully they do. You know, like the chocolate bars where you split the fingers. You get 2 chocolate bars attached, they like snap off into 2. Very cool. We're going to imagine that they're being sold. How do I draw a cent sign? I'm just going to draw a C. I'm going to get roasted by Keiichi for not knowing what a cent sign is in Europe. They use cents and euros in Europe. In Britain, we're a bit weird, so. Okay. There's Kit Kats there, great. I'm going to draw the cent symbol wrong if it really upsets you, say, but I can't be bothered. All right, so Keiichi, I want you to imagine you have 24 euros a week to do whatever you want, and your school sells Kit Kats. If they were being sold for 20 cents, how many Kit Kats would you buy a week is the question. 20 cents, how many Kit Kats? There's a slight delay, so I'm going to have to wait for a bit. And after that, the question is there's going to be each question. So after that, how many would you buy at 50 cents? And how much would you buy if it was a whole euro? I think you draw the euro symbol after the number, actually, but I don't care. I'm British and we do a pound. There isn't a cent symbol. Oh, Europe's dumb. Why is there not a cent symbol? 120? You only have 24 euros a week? What? Okay, you're confusing me. 24 euros divided by 0.5. Oh my goodness, you can buy 48 Kit Kats. But you're spending your entire allowance for that week on Kit Kats. Wait, in case when you put answers, can you put how much money it is for 1 Kit Kat and how many you buy? So for example, 20C, how many Kit Kats? 50C, how many Kit Kats? €1, how many Kit Kats? Yeah, no, but I'm imagining that they're being sold for 20 cents. I don't know how much they sold there. I don't really care. But it's like, how many would you buy? You wouldn't spend all your savings. This is what happens when you don't give kids pocket money, guys. They just don't understand the idea of like, that's the only money you have in a week. And you can spend it on all sorts. You can spend it on whatever else. You don't have to just spend it on Kit Kats. So it's like, how many Kit Kats would you get? Turns out we're not just teaching KOC economics, but also basic finance, guys. This is very exciting. You could spend all sorts. You could go to McDonald's, you could get clothes, you could go bowling with friends, go to the cinema, I don't know, buy a calculator, buy Rubik's Cubes, buy all sorts of other things at like toy shops and stuff. And there's other chocolates, other sweets. Oh, please ask your parents for some pocket money. It's so much fun. You get to choose what you spend your money on. It's great. It teaches you budgeting and stuff. Great fun. That's what a lot of us do here, especially in like Nottingham, where I'm from in England. We're a big fan of pocket money here, but I guess that's because we're in like a city centre type area. So we're all like city kids who like to go into the town and spend our pocket money on things. But yeah, so for each of the prices, got like type what price and how many Kit Kats you get. I need data. And while you do that, I'm going to get the data from my class. Yeah, but how many? Okay, well, what chocolate bar do you like? I just need I just need to know. I just need data. Look, I'll give an example of different numbers my class gave on this. So we'll leave this entry slot for you, and then this entry slot will be me. What's my name? Jump Ray. Wow, it's been a long day when you can't remember your name. Jump for short. Yum. So I put, what did I put? Oh, I put 7, 3, and 0. So if it was 20, in the UK it's 20p. So I would get 7 if it was that price. I think I've ruined the effect of this demonstration by just how little budgeting you've ever had to do in your life so far. It's just like, as far as I'm concerned, for someone who like does budgeting a lot, it's making me feel very sad. You've never had that as a thing to do. Oh man, it's actually breaking my heart. As an economist, I just can't. The fact you haven't done budgeting. Okay, well, even you maxing it out would still show the principle. It's not as much. Wow, I can't imagine that. It's like if you, hmm, no, I can't explain capitalism to someone who's never had much currency of their own. I really can't. That's what I'm trying to do. Um, one day you'll experience capitalism when you get a real job. Well, not a real job. Once you get employed and you get paid, you'll have money of your own, and it'll all click into place. What I'm saying now. But basically, what people do is they'll choose how much they want to buy of a thing based on how much they have. So I would buy 7 at 20 cents, 3 at 50 cents, and none at €1. Um, okay, I'll replace it with baguettes then. Do you want to choose some prices as well then? Okay, that's that's amazing. That because you're from France, I need to replace the Kit Kats with baguettes for it to make sense. Yeah, if you choose three prices that are like very cheap, pretty cheap, and quite expensive, are your three prices. And if you like choose a price for each, then I could do that. Yeah, if people don't spend that much on chocolate, absolutely, that's what I'm saying. Or if they did, they choose different chocolates. It wouldn't all be Kit Kats. You'd buy a range of different things. Like I went to get snacks recently, and I got like 3 packets of Maryland cookies, a bottle of Iron Brew, like some cans of Dr Pepper, and some jammy Dodgers. Like I'd spend my disposable income on more than just one treat if I was just getting treats. But apparently, if you had 24 cents, you'd spend it all on 24 euros. You'd spend it all on 20-cent Kit Kats. Absolute madness. Yeah. Did you get the bit about baguettes? If you didn't, I'll just choose a price. What seems reasonable for baguettes? Oh, you're gonna roast me for how unreasonable these prices are. We're gonna say 70 cents is my low price. I believe you do a dot, don't you, in front? Oh, you do a comma, I think. So I'll be inclusive and do that. Say €1.20 for my medium price, and like way too much, I would say, is a euro. Yeah, €1.10 is like oh, that's a bit expensive, I think. Oh really? Epic. Okay, so how much? So Kaish, you're given you get 24 euros a week. How much are you spending on baguettes at each of those prices? So if you just type, okay, a bit less. I can't be able to change it. I just need data. Come on, see Kaish. I'm just gonna resort to using my class data at this point. So yeah, that's the point. That's the point. Okay, 120 is too expensive. All right, fine. I'll change the numbers. Okay, so given that feedback, we'll say the upper limit is 140. I'm putting the euro sign in the wrong place because I'm a gangster. I don't care. 90 cent here, and the first one's meant to be pretty cheap. So if you're saying 70 is too expensive for a cheap bagel, then we'll go as low as like 40 cents. We're going cheap bagels. All right. Oh, you've gone with the other prices. That's fine. That's fine. Oh yeah, you're still buying bagels. Oh, why did I change the numbers? No, I'll change it back then. Okay. Oh, I thought you were telling me my prices were wrong, but you're still buying bagels. That's good. That means I did the prices right. Should have had more faith in myself. No, you got to assume that this is a hypothetical world where the product's the same quality regardless of price. I probably should have said that. Oh man, my economics professor would be so mad if you were the student. Like I even started questioning a bit, and they like got so annoyed. If you questioned it this much, they'd be so mad. So you're saying you get 34 for 70 cents. I think I went with €2.10 for the upper bound. So you get 34 for that many cents. How many are you getting for 120? You buy 20. How many would you buy at 210 euros? Please tell me you're not just maxing out again. If you're maxing out again, I'm actually just going to cry. I'm just going to give up. My economics lesson's over if you just... You just maxed out. Okay, you should stop. You meant to not spend all your money on one thing. I'm just going to have to highlight this stream of just economists gets fed up over kid who's never budgeted. No, you're not meant to spend all your money on baguettes. Stop it, Karish, you're killing me. Oh, I need to clip this and show my economics professor. They'd absolutely find it way too funny. Pain. I think what you said is valid. I just closed chat because I'm stupid. Let me try and get chat back. Oh no. Where's my chat gone? No. Oh, it's reloaded. If everyone just bought baguettes and nothing else. Okay. Oh God. Okay, if every single person who had currency spent it on nothing but baguettes, we'd be in big trouble. Because even the people making the baguettes wouldn't buy like the ingredients for baguettes; they'd just be buying more baguettes from somewhere else. So we'd just be circulating baguettes. At that point, baguettes would just become our currency, and that wouldn't be good because baguettes go off, and currency, it's very important it stays at the same price. So, what would happen if that happened? I think you'd have intense inflation. Inflation's where prices go up. So, for example, like in shops, if you wanted to even just buy like a bottle of milk, that would usually be like a euro for Europeans. It would like go up to like 1,000 euros for just a bottle of milk or something stupid like that. If everyone lived like you and just bought baguettes. I've given up trying to demonstrate my point. I don't know how to explain this concept to someone who's never budgeted in their life. No, it's a terrible idea. You don't want you do not want to have a currency that will devalue over time. That is a disastrous situation to be in. That's why all currency is valued in gold. So for every like euro you have, it will be corresponding to a certain amount of gold stored in a bank because gold doesn't lose its value. And you really need that for currency. It needs to be based on something that doesn't lose value. So if the currency was baguettes and it was based on baguettes, that would be terrible because like a baguette's gonna lose value over time. Yeah, that would be what would happen. It would start being 1,000 baguettes to buy milk, and you'd have like the World War II sort of situation, like in Germany, where like people would be carting dollars into stores to buy things. Like you'd be like have to have like a lorry to carry like 20p of real income. 20 cent of like real income. It'd be so bad. But you don't want only baguettes. Baguettes lose value because a baguette a week later isn't as good as a baguette now because it goes off. You don't want currency that loses value. I'm clipping this. It's just economist gets angry over non-budgeting kid. It's gonna get 1 million views in a week. It's gonna be such a great video, great clip. I've fully given up. I'm going to explain demand curves anyway, but from a purely theoretical perspective. Because I think that's the only way you're going to understand what I'm saying is if it's theoretical. Trying to apply it to the real world is just... No, but you're not meant to eat your money. You're not meant to just be given 20 euros in baguettes and just like eat it. That's not how currency works. With currency, you use it to buy other things. It's about exchanging it. So I think you know this, but you're successfully creating a huge humor for for my clip. Okay, let's just do supply and demand curve. So clearly not for K-Yoshi, but usually, so we got price here, and we've got sales here. What tends to happen is that the lower the price is, the more people buy it. So you end up with this lovely curve. so here, let's say the price was €4, then whatever this good is, people would tend to buy only like. And this is called economic analysis, by the way, where you draw on your dotted lines and you figure out what's going on. It's a pretty big part of economics. Then maybe this is 4 units sold because it's so expensive. But simply by decreasing the price, you'll increase your sales. So if you're trying to sell everything, or maybe trying to optimize amount made and amount sold, because I guess ideally you want all your stock to be sold, or most of your stock, because obviously every time you sell it, you make money. So you're trying to sell as many of the things you have. Sometimes you want to decrease price slightly so you'll sell more, or sometimes you want to increase price slightly so you sell less. This is a really common thing in like any market, and this is pretty sick. It's really cool usually because most people, okay, if you don't spend all their money on one thing, they don't just have €24 allowance for a week and spend it all on baguettes. They'll like budget more. So like you'll see people like in the class, like you ask them how many would you buy at this price, and they'd all decrease as the price decreases, like naturally, and it ends up like they create this curve, and it just shows just how fundamental it is. It's so cool. It didn't work today, but these things happen when you're streaming online, and just so happens you have an audience member who, yeah, would spend all their income on baguettes. No, they wouldn't be super cool and tasty. Your whole entire system would be an economic crisis. Okay, it would be terrible. So yeah, something the amount sold will go up to like 24 or something. So yeah, this is demand curves. It's really cool. Demand curves like blew my mind when I did it. It didn't work today, but maybe your mind's still blown from a. You have 2 cents left. And that's how many brain cells you'd have left as well after 3 weeks of living that way, because you're only buying baguettes, so you wouldn't have any vitamin C from vegetables, so you'd have crippling constipation and scurvy. What can you buy with 2 cents? Not a whole lot is the answer. Oh, you've exhausted me so much with your lack of budgeting experience that I can't even bring myself to go into PPFs, man. I don't know if you did. I don't feel like you can take away as much when your budgeting is that non-existent that you'd spend all your income on the same thing. I can't, man. I feel like you're joking, but I still can't tell. Part of me feels like you're actually that obsessed with pure mathematics you've forgotten how to be a person. That's going to be me in like 2-3 years' time. I'm going to forget how much bread costs because I've done that much pure maths. Just intense linear algebra and vector. What do they call them? Hilbert spaces. Yucky infinite dimensional linear algebra messes. Oh, I'm having an existential crisis now. Well, we covered demand curves. We did it. We did it. We did it. Yay. Oh dear. Where's the we did it theme? You've broken me that much, Kayoshi. I'm going to search Dora the Explorer, we did it. Like I explained, vitamin D, scurvy, constipation, nothing good if you don't buy vegetables. At least vegetables. And you'll need water too, probably. You need a healthy, balanced diet, man. Thank goodness they feed you well at your college. Because if you're left to your own devices, I'd be scared for your health, man. Yeah, this is me in my head right now after managing to explain demand curves to a non-budgeter. Hopefully it'll load so I can share the meme. Oh man. How many Facebook user seems about right. Oh man.
We did it. We went over the bridge and past patrol. Yeah, we did it. We did it. We did it. Hooray! We went up the mountain to through little stars.
I'm gonna listen to this whole thing over again.
We did it. We did it. We did it. Swiper hid little star in Tico's tree. That Santa, Tico Santa, and we found him. Hooray!
when you have an exam deadline the next day
Hooray!
and you're just procrastinating hard. Oh, I know the video that has this clip better. Oh, I know the clip which has. This is the video. I'm like deep into the realm of procrastination at this point. I mean, streaming was probably not the way to be productive. I thought it'd be alright, but it hasn't. Oh well, at least I feel a bit better. No, this video is sick, and it has the We Did It theme well. Yeah. I'll go back to actual stays in a sec.
We did it! We did it! Yay! Always team up. We did it!
There it is. Okay, back to maths. I'm gonna do some algorithms, I think, he says. I guess I'll do... Am I more productive now or less productive now? I can't even tell, man. I need more advanced economics so I can be productive, because that's what we learn about in economics. Have you not? It's a great meme. The whole of Dora the Explorer is great. There's a... I can't show it on stream because of trying to brand and like having the right age, but like there's this series that's kind of... Oh, I don't know if I'm going to recommend it or not. It's called Dora the Adult. Oh my goodness. Oh my goodness. But it's more fun if you've seen the original Dora the Explorer. You should just watch Dora the Explorer, honestly, man. Great stuff. The pinnacle of educational TV. Oh, but you've not heard the We Did It song? That's a big part of Dora the Explorer. Okay. Okay. I have a friend that I wish I had it called Dora more because it would have been hilarious, but I didn't really, and I'm sad now. Because she looked exactly like Dora. It would be the end of their career though. Oh, but you've heard about it, but you haven't seen it. But you should watch it, Keish. It's important you see Dora the Explorer. It's it's integral to your maths and computer science education. Oh dear. Oh dear. Alright, well, we're going to do some... Now I'm feeling more productive from having tried to explain demand curve to the least economically minded student I've ever encountered in my life. I guess that's the thing with economics. It either clicks or it doesn't. I think Keishi's IQ is just too high for economics, man. It's too big brain. Yeah, now we're going to do Maths Volume 1 Pure. Maths Volume 1 Year 2 Pure. Gonna try and remember what I did. Maths Volume 2, Volume 1, Year 2 Pure. Alright, so we did small angle approximations. Maybe we should do this on a text document. Text document. Yeah. And I could screenshot and put it on if I wanted to. I kind of do. So some people had a lot of Dora Explorer merch at school. It really did look fun. I think just like being really, really, really big fans of one like piece of literature that's like relevant to like the school or whatever you're in is like cool. I tried to get on board with that with Star Wars. And I thought the way to do it was just to watch every single Star Wars movie. But in the end, apparently most Star Wars fans don't watch all the Star Wars movies, so I end up just wasting my time. Still to this day, I don't know how you get involved in one particular thing. I guess I just need to get merch. Should have just got a Star Wars top and not even bothered watching the movies. Yeah, you know, small angle. I didn't even write for trigonometric functions, you already know. No, that's not how small angle approximations work. Oh no, it is. Yeah, we learn it slightly differently for cosine, but you're right for sine and sine and tan. Do you know the proof though? You probably do. Differentiating sine and first principles. I don't know if we need to know it for tan. I wished I was long ago with my family, but I don't remember it. If Fair enough. Fair enough. Yeah, no, this isn't the most entertaining stream ever. I mean, we've made it more entertaining for that last bit, but to be honest, I'm not even sure why I'm streaming it, but yeah, getting the derivative. Yeah. Just taking a function in x and saying how the gradient varies as x varies, you know, that good stuff. What else have we done? Oh, we've done the general binomial expansion. I've kind of already covered it, like relive learned is what I'm calling it, where like we cover it in class and I'm like mirroring outside class. I'm guessing you know how to differentiate sine x from first principles. I mean, if not, I can do that because that'll be interesting. Do you know how to differentiate tan x? Because I don't. So if you can teach me that, I'll be sick. The way I'll show you how I go about doing it, and you can like tell me if you know how to do it, because I don't at all. So what I would do is say fx equals some function in x, and then say given that's the case, then I'd state sort of as my first principles methodology, I'd say the derivative of fx equals differentiating tan x from first principles. I'd state that the derivative of fx is the limit as h approaches 0 of f of x plus h minus fx over h. And I can use this formula to differentiate sine and cosine from first principles, but I don't know how to use it to do tan x. I tried it one time, I couldn't figure it out. Oh yeah, no, it's not just, wait, you said you know how to differentiate basic trigonometry. Yeah, it's not just differentiate, it's differentiate from first principles. Don't know if you've done differentiation from first principle. I imagine you've done it for like, oh, it's really fun. It's seriously fun. It's unfun for polynomials, but it's really fun. For example, differentiating sine x from first principles. I don't know if you've ever done it before. It's actually like really fun because you end up with you can use this limit h approach here. You can just use the big L. It means the same thing because you end up with limit of sine. It's actually cool. Use the small angle approximations that we were doing before with double angle formula and all this stuff. Yeah, but we're doing it from first principles, and that's why I don't know how to do it. I'm guessing you've never done it either. The textbook is like such a troll. It shows how to do it for sine and cosine. Maybe just sine, and that just says, oh, it's the same thing for cosine and tan. And while it is just the same thing for cosine, I agree. It's like, I don't think it is as simple as just the same thing for cosine. For tan, sorry. Oh, this is an adventure. The problem is I've done it so much like this past week, just because when I found out about it, I was like, this is cool. So it's kind of lost its magic for me, but I'll talk about what you do, because I can. I'm not going to bother writing out capital L the thing. So what you do is do you know about double angle formulas? It's sine A plus B equals sine A cosine B plus sine B cosine A. So here it would be sine X, sine X, I'm just going to use S because pain, sine X cosine X, well, that's going to make it really unclear though, but you'll be able to follow probably, plus sine H cosine X, and you get this all on top of the fraction. So then to turn the sine H into, so to turn the sine H and cosine H into something else, because it's the limit as H approaches 0, so you can use the small angle formula basically. You know what by heart? Small angle approximations, or the derivative of sine x from first principles. I'm so confused. So that's why you use the small angles. So then you could say, so it'd be sine x, then you'd use a small angle approximation for cosine. You can use you can approximate sine of theta for small angles of theta to different levels of accuracy. it's approximately equal. If we're going to say, if we basically have to approximate it using a polynomial, you can use like 1 minus theta squared over 2. But there's more terms. Like there's like continually small powers, big powers of theta. So there's like theta to the 4, theta to the 6, etc. I don't remember the exact continuation of terms here, but I know there are more terms if you want them. The one we use on the course I'm doing is this approximation because it's a fair bit better than just approximating it as 1. It's not as lengthy as like 7 terms. And the reason why it's good to have this approximation for it is because it's a polynomial, so you can do more stuff with it and stuff. Yeah, I don't know the infinite development for sine. I didn't know sine had an infinite development. But this only works for small angles of theta, so. Oh yeah, well, we do it a bit different. In the UK we have weird education stuff, so we'd write 1 minus h squared. And instead of having sine h approaching 0, so therefore cosine of x in this term approaching 0, we convert this into h times by cosine x, basically. You probably see that coming, but yeah. And then say because h approaches 0. And in this case, the h actually cancels with the other h, so actually you do need to use a small angle approximation, so you can't just say sine of h approaches 0 as h approaches 0, you need to say that it approaches h first because of the small angle approximation. The problem is only Kayoshi and I am probably understanding what I'm saying here. I guess the general audience feels lost. Sorry. But there's so much maths to go into here, I just can't even. Why do you know that? That's the general formula, but is that the general formula as x approaches 0? Is the proposition I'm putting forwards. And also that would suggest that there would be plus rather than minus here, but here we're going minus theta squared over 2, so I don't think that general formula is where it comes from, but I could be wrong. Okay, anywho, yeah, I don't know why I'm streaming this. I guess I probably should like record it offline or something, but I streamed it anyway because I feel like the rest of this might be a lot more mundane, but I don't know. We'll see what happens because I'm kind of just wanting to like relive study, like I was sort of saying a bit earlier. I'm just trying to like mirror what we did in class to hopefully help it stick more. There's a minus sign. Where's the minus sign though? Oh, you can have minus 1 to the power of like n or n plus 1. Oh, so it's an alternating minus sign. Yeah, and again, do you hear my thing about is that for small angles of x or is that all angles of x? Because this one's, I thought specifically was because it was a small angle of x, or here I've written theta. Yeah, I know you meant you forgot it in your formula. I was just, what did I say? That's not what I said. My memory's non-existent. That's not a good position to be in when you've got lots of things you're supposed to memorize and stuff. Though because it's maths, it's less memory. Chemistry might be more important remembering. I remember the things I need to, though, I think. We've done Born-Haber cycles, and it's quite a bit of maths. It's not much memory stuff. It's not my method as such. I don't know which mathematician came up with this method, but it's very rigorous. So it's a good method if you really want to feel why the derivative of sine is cosine. This is a good method to feel that out, I would say, and to really convince yourself and others that that's the derivative. The only thing it assumes is double angle formula and small angle approximations. That's 2 big things actually, but each of those things is a lot more learnable than the derivative without using this kind of method, so it's a good method. UK education gets a what do you call brownie point there, because it sounds like you haven't really done it as much. Had I continue it, you'd just finish it, wouldn't you? So we're stating here, given this thing here, the limit is going to be, so the h here cancels with the h there. So you end up, and then here we've got sine x times by 1, so we just get sine x. So we get sine x over h here, minus sine x over h here from the end, or we have minus sine x. So those two will cancel out, obviously. The cosine, h cosine of x becomes just cosine of x because it cancels the h on the denominator. So we get plus cosine of x here. And then for the final term, it's minus h squared over 2, but then divided by the 2 leaves minus h over 2 times by the sine x. So minus h, we can put the sine x on top of the fraction if we wanted to, which I do. Remember, this capital L means as h approaches 0, so what will happen is in our next step, so these two just cancel to leave just cosine of x equals that. So because it will save me a lot of time, I'll just copy paste this whole expression and oh no, pain. What do you mean? I'm guessing you spotted your own mistakes, so I'm not even going to go into what it was. I'm guessing I'm still continuing with this proof, am I? It's not working out. I can't select all of it. There we go. That's the stuff. Oh, I realized it's gone off the screen because of my webcam. I was even talking about that before the stream, about how I need to remember that. I'll go with a new tab. So we got limit of this. Paste it a second time. So then, as I said, these two cancel. So we get rid of them. And then we just write a final line of reasoning. So this means limit as h approaches 0. So limit this as h approaches 0. Yeah, sorry. Can you see what's going on now? Oh, if any of it didn't make sense because my face was right in the way, then sorry. Yeah, I know. I keep forgetting my face is in the corner. I can explain any of that. Does it all make sense? Hopefully. Oh, the delay's gonna. I mean, I'm going to sit here for a few seconds. So that's okay. If any of it didn't make sense, I can go over it again. It's funny. This proof's become so routine for me. Like I forget that. Like when you first see it, like, oh, that's actually kind of cool. Just because it looks so cool. Like if people don't know much about maths, like just to do something on the board so that you can like show them what maths is kind of like. It's like a cool proof to do on a board to sort of show. It just looks really cool and there's a lot going on. It's a lot of juicy maths. Oh yeah, no, I don't get it either. I just memorize it. That's the approximate. You can prove it, you know. It's not even that hard to prove. I could go into that maybe. Why this is the approximate angle. You can use like a triangle with a sector, and it's really cool. Sorry, an arc length. And yeah, it's cool, but for another time. I'm just going to accept that is what cosine approximates to as small angles. Okay, so given that we're happy with how we got here, it's really easy to see how we get to a final answer of cosine x, because we're saying as limit, the limit of this as h approaches 0. So as h approaches 0, this whole term's going to approach 0 because it's h times by sine x over 2. So it gives us a final answer of cosine of x. So hence showing that that's the derivative. I'm guessing, other than the small angle approximation of cosine, that I managed to keep you the whole way, hopefully. If not, then that's a big sadness. It's going to be alright, because on Monday I go back to my educational institution place thing, and you can stay quite late there as well. And there's a whiteboard and stuff, so I can bring a camera. Do much better math stuff there. Because I don't have lag. Like when you write on a real whiteboard, there's no lag like there is here, which is just the worst. Alright, I don't know where Kayoshi's gone. Oh well. I'm assuming you got it also. We're going to move on. Okay, I think this is all I've done so far. Not very much. Not because I do it differently to you. There's a lot going on with small angle approximation. I mean, that, at the end of the day, that's what all it is, an approximation. So you got to take it with a bit of grain of salt, I think. I think the proof still works if you approximate cosine theta as 1 here. But to me, at least, it feels better to approximate it slightly better, just to be more convinced that it's right. But yeah. I guess we'll talk about Born-Haber cycles now because it seems like a thing to do. Going to go into the world of chemistry, Keiichi. It's going to be interesting how much chemistry I need to explain to get you up to speed with Born-Haber cycles. Born-Haber cycles is really advanced in terms of when it's taught and when you'd actually need it, at what level of chemist you'd need it. But as a mathematician, you can understand it well beyond actually needing it, or when it would usually be taught in the usual scheme of things, formal chemistry education. But that's why it approximates it well. Oh, you need to. Losing chemistry for the chemistry, losing Keiichi for the chemistry. Should have moved on to chemistry earlier, because it's useful to have someone who doesn't know chemistry, because then they can figure out how far from scratch you have to go to keep people on board. Oh well, that's all calm. This is a bit of a bodge stream anyway. Thanks anyway for joining even for a bit. Have fun with maths homework. Bye. Oh, I think he's gone. No. Alright, see you in a bit, Mr. Keiichi. Alright, back to addressing the offline YouTube viewers. So we're going to do some chemistry in a second. I'm just going to get some water. Maybe another time, we'll see. I think what will also be cool. Oh, Keiichi's going. I'll address the non-live viewers if Keiichi's here as well. That's cool. Bye. Yeah, what I think will be cool is just to like do some like offline content where I'll like try and find people in my education institution who are interested in learning about chemistry, and then can interact with them and then record the video, make an offline video. That'd be pretty cool. Should probably go back to precision maths learning as well at some point. The algorithm stuff. Chemistry. I guess I'll just do a really rough outline of Born-Haber cycles. So Born-Haber cycles, or HBCs, as I like to call them. Even though the letters are out of order, I just like to call them it that anyway. I should probably write the word Born-Haber cycles, but I'm trying to be quick with this. So the way it'll work is basically you need a whole bunch of enthalpy definitions. So let's go into those definitions first of all. So key enthalpy changes type things. So one is so what you can do, Hess's law sort of states it doesn't matter which way you go from reactants to products, it'll be the same total enthalpy change. So given that, we can assume for any reaction all the molecules turn to atoms even if they don't. And when they turn to atoms, we describe their the state of the substance as being gaseous, even if, like, if you had just atoms of oxygen. Whether or not that can actually happen is irrelevant. You can imagine it happening, but why it's gaseous, I don't know. No, wait, we can observe it with the noble gases. Pretty much all of them are heavy in terms of they have lots of electrons. So all of the noble gases have lots of electrons, but they're gases, and all the noble gases are monatomic. So it shows even when you go up to like the most highest atomic number noble gas, even with all the electrons there, even with the strength of the van der Waals forces because of all the electrons there, it's still a gas. So therefore, pretty much any other element less than the highest atomic number noble gas that is going to be a gas, because we call them noble gases. So it means that you can be pretty sure if you've got any element really, for the most part, if it's just an atom, it's going to be a gas because of the fact we can look at the noble gases. So one of the key ones of the enthalpy changes is of atomization, and it will always be to our gaseous atoms 1 mole. You're not doing mole with MOL like that. There's a lot of advanced chemistry going on, by the way, if you haven't done chemistry before. This is less to get you from scratch up to anything, and more so that I've got notes on this in verbal form for later on when I'm revising. I don't like the word revise. What would I call it instead? I guess if I need like a refresher on what's going on Born-Haber cycles, instead of reading notes, I could watch a video too. And instead of trying to find other videos I don't really like online, I could just make my own video things. And the reason why this is public, I guess, when I was talking to Kara, she was like, why is this public? But I guess it's because in case it's useful. And also I can clip it and take out useful clips if it's public. I could do it even if it's private, but it'd be cool on the clip to be like, this is the original video. So yeah, it does make sense to do it as a stream. I just forgot why I'd do it as a stream at the time. But I've remembered. So atomization is important. I'm going to go more fundamental than I need to with this, just to make sure I drive this point home for even myself or other people, of why ionization and electron affinity are important. So electrostaticality is a key theme in doesn't exist as a word. So I can choose whether it's double L or single L. I go with double L. Because you have electrostatic. Oh no, you'd usually go. I'm going to go like that. It's not an actual word, but it demonstrates a theme that's important. And the theme's so important that I'm going to coin that word for it just for now, because electrostaticality, which relates to the wider theme of attraction and repulsion. In wider nuclear / particle physics, you can have, as well as static electricity, you get like, is it called dynamic electricity? Basically you get currents and stuff, and so the attraction or repulsion might be more than just electrostatic. But in chemistry we only work with electrostatic attraction and repulsion for one reason or another. So electrostaticality is actually a key part of chemistry. There's 3 main types of bonding. You'll recall, all intramolecular bonding. We're only going to focus on that. We're not going to focus on intermolecular for now. There's covalent, there's ionic, and there's metallic. And although the key one where electrostaticality comes into play is ionic, obviously, because you have your plus and your minus ions going together, and in this case, that's why electron affinity and ionization are both important. You have a plus one and a minus one, so in order to create these ionic compounds, you're clearly going to have to add electrons or remove electrons from atoms to create these positive negative atoms, so they can, positive and negative species. Once it's positive or negative overall, it's no longer an atom, it's an ion. So that's painful, annoying chemistry terminology, but you can call it like or atomic species. There we go. Yeah, in order to make atomic species positive or negative, you're obviously going to have to do electron affinity or first ionization. But for the other ones, I'm trying to suggest it's kind of, although it's not as fundamental, it's like, you can imagine that it's still, like, it's not related, but it's kind of related electrostatically, because they're all related to this. I don't know if any of this is making any sense. To me it makes sense, and that's one of the key things of it, so it'll be useful in the future, for me at least. I don't know if it's going to make sense to anyone else. It'd be cool if I had someone else to find out if this makes sense or not, but it is what it is. So you have in a covalent bonding, you have your nuclei in the center. They have electrons orbiting the nuclei that aren't bond pairs, and you have your bond pairs like this, where the repulsion attraction balances out to hold it together covalently. In metallic, you got covalent bonding happening on like a bigger scale. So you might have like multiple cations like this, metal cations, and then have like a sea of delocalized electrons circulating between them, and you have this sort of mechanism going bit here. And with here, even that, you can imagine that. I don't know if we look at finding enthalpy of formation of metals using ionization or affinity enthalpies. I don't think we do. I guess because there's too much like particle physics going on here for you to do Hess's law to figure out the data without just. And it's easy to just. How do they do formation of metals? No, you wouldn't do formation of a metal because it's an element. Yeah, that's what it is. And if it's the enthalpy of formation of liquid metal, you just find it experimentally by melting the metal. You wouldn't bother with anything else. So that's why. So it only really applies to ionic, but that's still useful to realize that. But ionic is fairly common. And it's what comes into this topic, Born-Haber cycles, HBCs. Forming ionic compounds is basically what we look at most, because I guess it's because it's the one where the particle physics is simple enough that we can actually do it. I guess with covalent and metallic, I keep wanting to use the first principles. It's not quite technical, but I'm going to use it anyway. It's like what we're doing here with this topic is we're really looking at how we do enthalpies of formation of ionic compounds from first principles, because measuring it directly is not a thing we can really do. Yeah, that's the thing. Because if it's solid metal or if it's elemental covalent simple molecule thing, like for example fluorine gas, we wouldn't really have its formation because it's an element already. Whereas an ionic compound, we need the formation of that because it's not an element, it's got two elements. So it's useful, we can use all these different things. It's crazy, we learn all these definitions just so we can do this one thing of finding the enthalpy of formation of an ionic compound. Okay, I'm going to work from fundamental upwards, like 4 ionic compounds is now what I'm doing. Focus 4 ionic compounds. And not only is it a focus, that seems to be all it's for, but I didn't realise that at the time. Now I did, and that's good. It's going to help me remember it and stuff. Okay, so we got ionization. P of ionization. Forming cations. 1 mole. And then we've got, I'm not gonna do it as a key point because it's sort of one of those things that's like a logical structure you have to know, but basically you can only do 1 electron at once. So this is lose electron. For electron affinity, we literally call it electron affinity. Or just affinity for short, I guess. Gain electron. Forming anions. I remember I said I was going to do it like that. You can sort of build up this picture. It's pretty cool. Apparently you're meant to memorize the exact definitions, but I think understanding what's going on is quite useful too. I guess that's what I'll focus on for now because it's easier to do in spoken format. And that's kind of the idea, so that I could save time by doing stuff in spoken format rather than just sitting and writing notes, which is just no fun. Type it and talk instead. Apparently this is fairly common, you know. A lot of people just talk to themselves though, so I thought it's kind of cool. Instead of doing that, just make a video at the same time. Oh well, at least I turned this stream into something that's, yeah, better than nothing. Okay, so that's our stage 1 of this model of Born-Haber cycles, and a further look at enthalpy changes. We only look at in year 1. This is year 2 of the chemistry level 3 course that I'm doing. in year one we only looked at formally at enthalpy of formation and combustion, but it was sort of hinted at neutralization and what else was there? Displacement. Enthalpies also existed, but we didn't look at them. Whereas here we're going to be looking at a lot more. So this is sort of, we make atoms and then we make ions. And the key thing to know is that before it can gain an electron, there needs to be an electron to gain. So when we construct a Born-Haber cycle, we'll always do the ionizations first, and then the electron affinity goes second, because we need to have the electrons taken off the atomic species to become cations first before we can dump it on the atomic species to become anions. Which also anions and cations like pretty much always tend to be metals for the cations and non-metals for the anions. The exception to that is hydrogen, which loses an electron to become a cation. But like other than that, cations, metals, anions, non-metals. That's GCSE chemistry stuff, so it's kind of irrelevant here. That's like a given. Okay. Continuation of enthalpy change mission ting. Okay, so what else might we need to do? So those are our fundamentals. Well, maybe we'll just put a title. Fundamentals. I guess bond enthalpy is probably quite important. We haven't looked at this yet, but I'm guessing maybe you could atomize first and then bond enthalpy second. Seems reasonable. 1. Fundamentals 2. Bond enthalpy. We go mean bond enthalpy. The theory on that's not too complicated. It's just, as you can probably imagine, let's say it's a carbon-hydrogen bond. As you can imagine, depending on what the rest of the species is, my mouse draws quicker than my drawing tablet, so it's a drawing tablet lag thing rather than anything else. That's good to know. Maybe it's because the drivers are messed up, so I should probably fix that. But as you can imagine, regardless of the rest of the compound, which I'm drawing like this, sorry, the carbon-hydrogen bond enthalpy changes depending on what the rest of the compound is, because as is sort of assumed knowledge at this point, covalent bonds are always going to be slightly polar if the atom on either end of the covalent bond are not the same, because different atoms have different electronegativities, so they'll pull the bond pair more or less, which will cause more or less electrostatic attraction on the rest of the stuff going on here. So the carbon-hydrogen bond will be different depending on what's around it. So the bond enthalpy of one bond, it's going to be different depending on where the bond is situated. So for values, you kind of have to use like an average of kind of what it's like in different ones, what the average of that is. So you can use it in any situation without having to specialize it. Yeah, I'm going to do it like that. It's kind of more fundamental if it was actual, but means so much more useful, and you can kind of, it feels kind of fundamental, so it's kind of okay. Okay. Sorry, I just heard something somewhere. I think it's fine. I think it's just something next door. Okay, yeah. Sorry. Right. Gosh, someone's really shouting. I don't know what that's about. Okay. Right. Alright, part thing free. So then to bring all of this together, sort of what you can do is the goal is formation enthalpy. And sort of remaining thing not fundamental to get to formation of ionic compound is lattice formation enthalpy. Formation enthalpy, yeah, it makes sense. It's sort of more formation enthalpy. This bit will be better talking than written, which is kind of why I'm doing this video. Sometimes the talking transfer of information is better than the than written transfer. Like written notes just like takes so many words, where you can just written just takes one where you can just like talk and it makes sense. So formation enthalpy, it's more based on like empiricalism. I already understand the idea of, like, sort of constructed the idea. For me personally, like my own philosophy of things. But for other people, like I'll try and explain it a bit. So you got empiricalism and ontology. So ontology is whereas like it's theoretical. It's like you're not focusing on really anything of the physical world. It happens a lot in maths and stuff. For example, a quadratic, like unless you apply it to something of the real world, it's not. It's kind of just there as its own independent thing. It sort of exists as a logical demonstration rather than as a useful mechanical component of the empirical world. So that's quite a useful distinction in especially like science, maths and stuff, especially chemistry. It's quite useful to switch between them. So some things in chemistry are very like ontology based, and I really like ontology. Like all of this is sort of, I use the word fundamental, but it's all ontology. So you can just imagine the molecules splitting into atoms and then gaining or losing charge, which is a very fundamental idea. Whereas formation enthalpy, it's not really based on anything fundamental. It's not like the enthalpy to form a compound from its atoms in the gaseous state. That's sort of, that doesn't actually exist, I don't think. Not that we've been taught anyway. It's not really an enthalpy people care about, even though it's really fundamental. So this is more based on empiricalism. And the way it works is it's the enthalpy change to, and this is a definition we have to memorize, so, but it's not too hard to memorize. It just explains what it is really well. It's the enthalpy change to form 1 mole of compound from its constituent elements in their standard states under standard conditions. And what that means is that that really it's like it's to say, for example, we had a compound that contained, I was just going to say carbon, hydrogen, oxygen. It's kind of boring, but let's just go with that. Contains carbon, hydrogen, oxygen. So it's quite like an empirical way to think about it. It's a bit fundamental. It's quite empirical. It's just say let's get some nitrogen, let's get some carbon, let's get some hydrogen, let's get some oxygen, and how much enthalpy change would it take for those 3 things to go and then turn into the compound. So yeah, but because it's not from atoms, when you calculate the enthalpy change using Hess cycles, you'll need to go. There's a number of ways you could do it. You could use it using combustion enthalpy data actually, because sometimes it's quite useful, quite easy empirically to just burn it rather than to turn it into atoms. You could do either empirically, but oftentimes burning it's easier and you'll get more accurate data. So that can be a way you can construct the Hess cycle. But you could construct a Hess cycle that involved turning it into atoms, and then I think, yeah, because we've got bond enthalpy, and then you could use the enthalpies of bonds. We don't really do that so often though. I don't know why. It's probably a good reason for it. I guess because it's mean bond enthalpies, it's not as accurate, so hence why we just use combustion data instead. Something like that. Okay, you get the idea. You also use it formation enthalpy data, calculated one way or another, to calculate the enthalpy change of a reaction. But this is year 1 stuff, and we're moving on to year 2, so I'm not going to bother doing that. I should have done the video on the year 1 stuff. I don't know why I don't do chemistry more. It works really well for this spoken format. I don't think I'm ever going to write chemistry notes ever again. I'll just do this each time. This is great. Okay, right. Lattice formation enthalpy. So using lattice formation enthalpy, these 3 fundamentals, you can get the formation enthalpy of ionic compounds. Yay. And then we got good for empiricalism 1. Is that not a word? Empiricalism. It's a great word if it doesn't. Empiricism? Empiricism? Is that the word for it? That's gross. I might just say empiricalism anyway. Oh, that's grim. What should just be some next level different thing? Like, what should just be like the ligament in a donkey's left knee or something? The theory that all knowledge is based, yeah, no. Empiricism. I'm going to call it empiricalism because I know it's wrong, but I've been using it so much that I feel like, because empirical is a cool word, so using that stem like more phonetically in the word for empiricism seems more fun than to do that. Good for but now that I know it's wrong and that there is a word for it, is going to hurt. I guess I've just got to get used to being more formal with academic communication. This is why I prefer ontology. Stupid empiricism. Is that how you pronounce it as well? That's what I'm going to go with it for now until someone tells me that's not how you pronounce it. Oh, good for empiricism. What is good for empiricism? Oh yeah, enthalpy of combustion. Definition that we've already learned, so it's really stuck in us. I guess the new ones we learn lots of them, and it's kind of intimidating, but so it's not too bad. And then there's part 2, which is if you need to get enthalpy of solution, calculate directly is hard. So what you can do is you can just do enthalpy of lattice dissociation, which you could get. I don't know how you could get that. But apparently, it's easier to get than enthalpy of solution. Otherwise, it wouldn't exist. Because this is only, I believe, only ontological. I believe each of these are, because I don't think lattice dissociation really ever happens. I mean, association happens, I think, maybe. I don't know. I don't actually know the process. You don't actually need to know the process to calculate enthalpies, and that's why this topic is so cool. Hess's law is really useful. It's what creates this whole topic, which is it's a good thing to have as a chemist. So yeah, I think I pretty much covered this, and you can learn these. And I guess I should explain it more, but I'm just not in the mood. And this is still better than nothing. Better than no notes. Better than no thinking about the stuff done in chemistry class before next chemistry class. I have homeworks I should do too. Those would be good. How did I do on my exploration of that was a good chemistry session. I feel. Oh, and that's not all the chemistry. We did some horrible empirical inorganic chemistry stuff too. You can't just diagrammatically work through that quickly. It's just facts. You have to know about different elements, compounds, and their physical electrostatic configuration things. And honestly, no one cares. This is why I should have done computer science instead, but the course was just too much, so I have to learn about inorganic chemistry. Yay. I don't know how anyone gets excited about inorganic chemistry. I really wish I did. This is quite intimidating looking. Should name one of these chemistry just so I can find it relative to everything else. Oh, that's the first one. Chemistry moment1.txt. And now, let's put it up there. Wait, let me change its name up here. Oh, it will. Switched it to slash, but it's still there. There it is. So, okay, now I know where the other ones are. Oh, here it is. Maths volume. Turns out having chat is distracting. But then again, it meant that I'm actually glad she came, because it meant that I was more able to focus because I'd be able to have that banter, the economic stuff, which is a great clip, like I said. So yeah, huge thanks Kiyoshi, it's actually hugely appreciated. Because now I can be more productive now. Everyone wins. What a friend to have. Actually blessed because of it. Alright, that's volume 1, year 2, pure. Small angle approximations, differentiating sine, cosine from first principles. Should probably do some research, and if I need to know 10x, I could always have a look online if there's a website on it. Live research poggers, okay. Hey, it's got results. And that's a result. I got a YouTube video. Usually that would be the thing to do, but... Ooh. Ooh. Oh gosh, okay. Let's have a look through this. So the derivative is 1 over cosine squared, or secant squared, but no one likes secant. So you can think about it as 1 over cosine squared. What the heck's going on? So it's stating y plus delta y equals tan x plus delta x. So tan x plus delta x equals that. Fair enough. Okay, we've got this. Fine. Got this. Don't know why they're just bringing that in out of nowhere. Okay, I got this. I got there. How are they able to take out sine x and cosine x? Oh, because they got delta y. And they're taking away y on that side. Okay. No, I don't follow. Why is that delta y? That bit of the reasoning is getting me. It's not really being a thing. So I'm guessing we're going from, oh no, yeah, so this equation here, we're going from here straight into here. Okay. I think this makes bad quality stream, but this is more for like personal notes. Oh gosh. What's this lad doing? Let's just go through to the working and trust that it's fine. Dividing through by cosine squared x, cosine delta x. Oh, that's cool. This is some next level manipulating. Is delta y over delta x what we need? Oh gosh, we're going to approach either delta x or delta y to 0 to get a derivative. Okay. I don't know why I'm reading this. Both seems like a good idea and not a good idea at the same time. So it's saying 1 plus tan x squared equals secant squared. So then we're swapping out that for secant squared. Limit of delta y over delta x equals limit of that as delta x approaches 0. Apparently you can just take out secant squared. Limit of delta tan x over tan x equals 1. Yeah, because that is small angle approximations, that approaches approximately is delta x. Ah. So it wasn't that when I was doing it, I didn't know anything that I needed to know. I mean, I didn't realize I'd be able to use this identity. I assumed I'd probably use something like that identity. It makes sense. So basically we're trying to get to tan x squared somewhere, tan squared x somewhere. The key to there was some intense algebraic manipulations here, and this madness to get to a form where there's tan squared x. So it's not that any of it does maths that I've just never seen before, it's that doing it in that sequence is really hard, because I was trying to do it in a notebook I had one time when I had like 20 minutes through. We were meant to be listening to to presentation on ethanol consumption, or like alcohol/beer, as it's like more commonly referred to as. But I think when you're confronting big issues like people drinking too much, breaking it down to its fundamentals of what they actually do, and they're consuming ethanol, why are they doing it? I don't know. Let's look into why. I think is useful to like step back from the emotional side of the problem to really figure out what's going on. But that's just my take on stuff like that. Anywho, that's what it was on. It was on ethanol consumption and how lots of it's bad because ethanol's kind of toxic to the body, I think, and the liver has to break it down. So when you consume too much of it, it like really breaks away at your liver. People do it anyway. People do dumber things than consuming lots of ethanol, but that is one of the dumb things we do. And for some reason, it's culturally like a huge thing. But then again, like I said, we do lots of dumb things. I don't know why people suddenly get really obsessed over one small thing that we do wrong. It's like, yeah, we do lots of things stupidly as humanity. Anyway, that's what the presentation was on, but I was like, I don't know, I just wasn't feeling it. I probably should have, and my brain just got so distracted, so I started trying to differentiate 10x when I probably should have been paying more attention, but here's what it is. So this is what I need to do. Like, I got to this kind of stuff. Oh, I wish I had the notebook with me. It's at school, unfortunately, but I can show you what happened. But now that I know that it's within my grasp, I just have to like work really hard to get it into. Maybe I should write down this form to know this is what I'm working towards. Is this really the formula for it? I thought it was tan squared x plus secant squared x was 1. I don't realize it's like that. I might have copied that down in a notebook wrong. I need to remember that then. Sorry. I don't know how I'm going to remember this formula, but now I know I need that identity and that it's not as simple as tan squared x plus secant squared x. It'll make it easier to do without any notes or anything if I'm going to try and differentiate tan x from first principles again. I'm going to learn this because this is a hardcore proof. Imagine just like walking up to a whiteboard somewhere, there's just some people chilling and just writing out the proof that the derivative of tan x is secant squared x from first principles. Look at how hardcore this looks and is. That's amazing. That's something to like learn. I don't want to learn it by just like reading through it and memorizing what's going on. I want to do it for myself from knowing roughly what's going on. So that's the mission one day. But it's cool that now that I'm aware that it's doable, it's within my skill level, it's just hard. And there's some things to remember, like the identity. And you have to do a weird divide by cosine squared plus cosine delta x. Madness. Okay. So now I've covered that bit too. For these 3 things, I've done quite a lot on each of these. Although I've not got formal notes perfectly. One sec, I'm just going to go check what's happening because I hear some things and I just want to check things are going on. Alright. I'm going to put on the same stream music at the beginning because I can. Hi back guys, hopefully. Yeah, so I got some good notes on this. This is like done because I did that much messing around with it. The general binomial expansion is pretty much done because I worked on it before term. So I get some more float out. There's also some calculus things which I just can't go with. So yeah, whatever. I guess I should do a thing on algebraic fractions moment. Probably should do, but I don't know if I can be bothered. It's not as urgent. And I should sleep at some point as well. These are all things to think about. I'll be back soon. Alright, bye. Oh, sorry, I don't know how long you've been sitting inside the music video. Alright, I'm back. Our food. Things happen. Life goes on. But yeah. I don't know if I want a knife for this or not. I've got some rice, some chicken stuff. Yay. So, yeah. Further math stuff to be done. Probably do something to keep stream viewers entertained, but I'm not a good streamer. It's interesting, the Sidemen videos creator team thing, I found this. The viewers really like watching people eat or something. I don't know why that's a thing. So apparently even me like eating this now makes better stream content, but I don't know why or how. Doesn't make sense to me. So yeah. Not usually the biggest fan of chicken, as indicated by video chicken on my my video art channel, Jump Ray. But this is alright. So yeah. Got a bit of a kick to it though. A bit spicy, but not too spicy and stuff. Alright, remember to turn the microphone back on, and that's always a good start. Okay, it's weird. I used to do 4 main courses. So I used to do 3 main courses. I used to do maths, chemistry, and computer science, and now I only do maths and chemistry. And then I do like a smaller course thing in both economics and computer science. So it feels weird having that 3rd subject gone. I miss doing those 3 together. But yeah, that's what it is. I do maths in 2 parts, 2 volumes to it. As probably previously mentioned, one part's just called maths, and the second part's called further maths, which is like pretty much just called it more maths. I've said this a million times on my videos. It's like a thing I keep saying, but still just can't. I can't really understand the fact it's actually named that. It's actually just do maths. It's just in 2 parts. We've done a fair bit of volume 1 maths in terms of not quite a bit of small angle approximations, writing sine, cosine, first principle. I've done this before. I haven't done it. Partial fractions is cool. Really understand what's going on there. There's a research task I need to do, really. Let me just add that. I really like research stuff. It's just weird that I'm splitting it now between relive studies and notes and research, because before I used to like categorize it as the same thing. I never picked up on the fact it'd be good to categorize it differently. But it is good to categorize it differently, so it's just as why I picked up on that, really. So picking up that categorizing it differently would be worthwhile. So yeah, so that's what I need to do now, is instead of just putting it all in one big list, split it into research and RLS, relive studies. Yeah, I did some RLS on small angle approximations, differentiating sine, cosine. I really want to do RLS on year 1 trig, but year 1 trigonometry, but unfortunately it's kind of too basic, mate. You need to do other things. If only studies could be the same as year 1, where things were survivable, made sense and all that good stuff. Speaking of which, I don't know what I need to do with year 2, with volume 2 maths. Volume 2 maths, that's what I should probably do now. It's just a dull time all round. Man, I wish it's like Kyoshi. Oh, I've got my stream chat. Just think I should open that just in case I get any. It's not going to happen, is it? Also, I'm going to set like about 28-minute time. I've already spoken about moving sites, moving schools, haven't I? There's a lot of stuff to really explore there. I just don't know how to do it effectively. Oh, I mentioned the talent show, didn't I? I mentioned that I wanted to do stand-up comedy for it, and that I'm going to need to practice that a lot. Oh man. So gonna need to start practicing on that at some point. I guess the stream is good practice, even though it's not comedy. At least it's talking skills, and that's useful. Thinking on your feet and all that good stuff in it. All right. Gosh, that was kind of spicy. I wish I had more of it. I could go downstairs and get more, but like, there's studies to be done. Okay. I wish the lag wasn't on the drawing tablet. Like, if there wasn't lag on it, I think I'd be unstoppable. So as soon as all I need to do is just get the drivers for it. And then, yeah, so my productivity is going to spike and go through the roof. It's going to be phenomenal. Okay. So let's get some tunes. To get tunes, I need to put that. No, hello. Put that there, and then play tunes while I get more tunes. I'll play my release, Silicon Ice Cream Sandwich by me. Maybe the worst piece of music to ever be released. That's alright, I guess. Alright, enough of that garbage music. To be honest, it sounds fine when you have silence and then you have it. But when you've just listened to like an artist like Kamex, who's like so much better at mixing music, it just isn't. It's just not it, man. It's just the frequencies are so filled. That's what I'm failing at. Need to improve that. But that's like hard. That's like hard sound engineering stuff. That's why most musicians. I'm drowning myself out with music. That's why most musicians like will never like sell music to the point of like the really successful musicians, because it's hard to get it well mixed. And once you do, it's like your music just becomes a million times better, but it's just hard to do. Yeah, what music do I fancy? Absolutely, yes. Okay. Oh, I need to choose some things, don't I? Oh, there's some cool Leave stuff. Big fan of Leave stuff, spelled with TVs. Oh no. Hey, that's good. That's good. I can work with that. Just about, maybe. He says, while slowly falling into insanity. I don't know. I have so many tracks now, by the way. Like, we're never going to run out of music tracks after what I've done here. Oh my goodness. That's the stuff we need. I'll show you the fruits of my labour in a second. Right now I'm just going to stack as many as possible before switching cameras again. Wow, I don't know why I didn't just show that on stream. Maybe it was a good idea not to. I don't know. As you can probably tell, I don't know what I'm doing anymore. Just kidding, I kind of do. Yeah, look, we got loads of tracks, stacked them. I don't know why I stacked it so hard. But then again, I'm going to be reading a textbook and taking written copy notes on it for a bit, so maybe we do need lots. I'm going to start with an absolute banger, K-Rounds theme from Deltarune. This is the stuff you need for for copying textbook notes stuff. I had to find it first. Yeah. Alright, found it. Easy. Easy clap. Don't know why I'm copying the notes. Don't question it anymore. I know what I'm doing. Nice. You know how you get observational comedians? Like this, I do observational content, where it's like just normal things but focusing. Oh, it loops. Alright. Probably fade this out, it's getting a bit repetitive. Probably next. I don't know, I'll choose one to go. Oh, there's nothing interesting here. I've messed it all up, guys. I'll go for a basic thing of struggles intensely. By the way, this is just me auditioning to be the DJ at our school sixth form end of year prom thing. Please sign me up if you're watching this, student council. Hopefully there'll be a way this will be found and I'll be the DJ. I'll be sick. I might just keep saying it in my videos until eventually it just happens for the meme. Where is it? There's one track that'll be good here. Oh, I found it. Yeah. Oh yeah, sick DJ. Can't find the track he's looking for. Oh yeah, definitely. Help. Okay, this song's actually banger. Oh wait. Yeah, this song's actually banger. I always forget how good it is. New sun gaze release. This is cool. It's super trippy though. Like I'll play at the same time. Like the rhythm's kind of like, and the tempo's kind of off. So there's like a slow bit and a fast bit go on top of each other. It's super trippy. Just too slow. Tempo. I get to this bit. Well, unfortunately, I've finished what I was doing, so I don't need the music anymore. But it's kind of sad because there's songs. Yeah, but I'll like leave a link in the description. Maybe we'll see. If it's not, just like yell at me. Be like, yo, add this thing. I mean, it's got its name here, it's Sungazer Threshold. You know what? I don't need to put it in the description. That can be searched and stuff. Yeah. Okay. Okay. So this is the list thing. There's nothing worthwhile here that should be streamed because it's not interesting content. This is just useful for me. It's just a stream in a nutshell. But I seem to be more productive doing it as a live stream. I don't know why. Makes 0 sense. Oh, this is such a meme. I wish there were people into this kind of meme, like technical memes, where you're like doing something where it's like it's a meme because it's like so technical and like specific and dumb. It's like, why are you doing this? So given all of this, there's like certain things here I can look at that I can disregard. Do we not just like I'm switching exam boards basically for Maths Volume 2 from 1 to know. It seems that the exam board I'm moving to just doesn't use rational functions at all. And I find that very sad because rational functions are cool. I can't believe it. That's depressing. I mean, I was bad at that topic, so maybe it's a good thing it's gone, but it's kind of sad. Everything else gets used except for rational. Oh, what about conics? Where are the conics? Oh, that's unacceptable. There's no conics on my new exam board for further maths A level. Wow. Wow. That is the literal definition of depressing. Not having conics on the further maths A level specification list. Oh, actually, what are they playing at? Conics are cool. Oh, I'm gonna hold conics close to my heart because they are good things and they serve me well. Okay, well now I have data and lots of it, good, tasty, lots of it data. Yeah. So what am I going to use with that data? Let me write that bit down. Obsoleted. And then a big sad face, or lots of them. Because no one likes obsoleted stuff. I don't know how you spell obsoleted. That's the obsoleted spelling of obsoleted. Okay. Conics no longer existing and rational functions. And then we'll do more of spamming sad faces. Yeah, that's the stuff. There we go. Okay, well, after some chat. And we're covering the things that I did last year again anyway. The sequence and series I guess I need to retrieve. Oh, it's what a shambles. No wonder I was struggling to figure out what the heck was going on with it. So do I need to cover year 1 or do I not need to cover year 1? I guess for retention it's a good idea to recover year 1. I guess I could do it a bit now maybe if I wanted to. Don't know if I do or not though. I'm going to put this on in the background quieter. Yeah. This bit doesn't really work as background music. To be honest, this whole song, I'm not sure about it. I mean, the visuals for it is really good in the music video, but like the song itself, like if you take it away from the music video, it's kind of just weird, if you ask me. And I've listened to it a lot of times over as well. The first time I was like, this is really weird, I don't like it, but then after a few listens it grew on me a bit, but now I'm sort of going full circle and being like, no, it's bad. I don't know, man. Okay. So trying to decide what I'm going to do. I guess I'll construct my year 1 and my year 2 for the further maths based on what things I did last year, what things I didn't, and if I didn't do it last year, then I'll include it as part of this year, even though it's different. Or I could put it in a bridge, so we'll have year 1 bridge, year 2. There's only one thing in the bridge, 2 things in the bridge. So we got 3-dimensional matrices determinant and the vector product are the 2 things that sit in the bridge. Everything else is either year 1 or year 2. And year 1's now reduced, the amount of stuff in year 1, because of switching exam boards causing mayhem in my studies of A-level further maths. No one cares, I don't know why I'm going to this. It's just a thing I need to do, a technicality. Anyway, it's done now, so that's cool. Topic list. This is poggers. Oh gosh. Is this serious lag, or is it the mouse is broken? Find out after the break. Whoa. Whoa. Okay. All those documents. Ah! Obviously, documents actually going to be quite useful. Yeah, 1. I'm going to go try and do all of this on one just because complex numbers. I should make it all official and stuff. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, 12th chapter, I can do it official. We'll call it the old one spec A. And the new one, well, that's the end of threshold rip. A. So I think I can get rid. I can return the year 2. It's not as useful though, is it? Maybe I could buy another year 1 spec A textbook. That's probably what I should do. And I can return both. Yeah, I'll do that. Okay, that's good. Now I know. This has been really productive. Streaming makes me more productive at studies. Why is this a thing? Does anyone else have this or no? Actually done. Chapter 5, hyperbolics 1. Oh, you know what? I need more music first, don't I? Yay, I can go through more of this. I haven't had Dusk for a while. There's so much more of the track left. That's the end. Weird. Okay. Yeah, so I'm just trying to figure out. Crown series, probably repeat of year 1. Oh yeah, that's that part of it. Chapter 12 then. Oh yeah, induction. Where's the... Excluding series. So then when do they do induction? Old series and induction are done, so they do it then, but then I don't because I've already done it. Okay. Induction. Both years of Spec B. Okay, so that's year 1. And bridge, we got... Oh, I should get airport terminal. Why am I streaming slow? But this is cool. It's not cool. The quality of stuff's gone down, but the productivity's gone up, and that's kind of why the stream exists. And it's the end of the stream, and no one's going to watch all the stream anyway, or watch the stream at all, so it doesn't really matter if there's just like garbage content. Yeah, it's fine. What's not fine is me forgetting how to do anything in a stream. That's dumb. You'll need to remember it's all over there to do that. But while we do that, I'll the best filler music ever, Sungazer's new release. Is that a roast or is it not? I don't know. Okay. Oh, there's so many tracks. This might not be a good idea. Pushing computers to the limits. I've forgotten the main one I came for though. I'm trying to remember what it was. There's one that I was like, oh yeah, that'd be cool. Oh, I know what it is. It's definitely worth pausing stream before to do. I mean, the whole thing is just, this whole stream is like, what? Too much. No, you're not. Yeah, just put the volume down. There we go. Sorted. Okay. There it is. Legendary track. Okay. Yeah, get this garbage serious music out of there. We only want the best of tunes. Nice.
At the airport terminal, the planes are landing. Traveling somewhere and it feels fantastic. Rolling across the terminal floor. And the sky's so high and the ground so low. And I think I'm dying, but I'm just being born. At the airport terminal, the planes are landing. And through the terminal we all shall go. At the airport terminal, I feel so
Might split into bridge 1 and bridge 2.
Everybody here is having an unusual day. It's 10:24 in an unusual time zone, and I'm feeling fine in an unusual way. And we're going so high as I'm flying so low, and I'm saying goodbye to the world I know. At the airport terminal, the planes are landing. Through the terminal, we all can grow. And it's time.
Alright, caught that negativity. There we go.
But I'm lying down on the terminal floor, and I'm running toward the terminal door. And I'm eating porridge, but I've heated it for the wrong amount of time. At the airport terminal, I feel so imaginative, imagining where all the planes are going. And when I'm there, I'll imagine where I came from, and I'll imagine my way.
interesting. That's about time to wrap things up if I can load. Okay, nearly done with this anyway. Is that all? Yeah, and the rest. Okay, that's a pretty productive document right there. And by minimizing it, it's now lost forever. No, I'm kidding, I'll be able to find it. Okay, so now that I know what's where, help me to, oh, I can't believe conics and rationals are gone. They were no good anyway. Learning being wasted always hurts, but it's kind of nice. It's kind of a relief actually having learning released, given especially that it's got other things I have to learn. It's like all this decision stuff. Well, I was showing earlier in the stream. See, making a cyclical nature to the storytelling narrative. Great streamer, yeah. Oh no. Okay. Yeah, this stuff I was talking about earlier in the stream. I don't know what problem types is meant to mean. All of it's probably best learned off stream rather than on stream. Okay, learning new things, knowing what's good for stream, what's not good for stream. Yeah, I'm just trying to look at my list of objectives and how they went. I think all in all, it's pretty good. Yeah. So now I know big things are catching up on the decision maths topics. And that I should like do the recap of pure maths sooner at the weekend, and I should like think about like there's a whole section of like the studies I'm going to call like withhold, where it's like, what does withhold mean? I'm going to call it withhold, even if, you know what, I have a dictionary out, let's use that. Such a vibe thing. Oh my goodness. Oh, that's cool. Yeah, it's like withholding it to the void of ignorance. Wow, that's cool. Suppress or hold back. Yeah, withhold. So withhold studies for me are going to be like doing things I did last year, but like recapping them. So I should do like a withhold thing every so often. So having known that, I could have just chosen one before the stream and done that. I didn't really think about it properly, but now I know. I've learned a lot from doing that. What do I want to do now? I should probably stop stream and then start it again if that's a good idea, but probably won't be. I think lots was covered. I think the only way I'm going to regain productivity is either by taking a break or ending stream, so I could take a break, but I guess it's probably time to end. So I guess I should do like one last cool thing and then end. Oh, are there any cool problems I can get? Don't know if there are or not. Is there nothing cool I can do for the last thing? Let's do a quick research into are there any of these are quicker beat? So all dull, slow stuff it is, isn't it? Oh, this is kind of cool. Oh yeah, hyped. Okay, now that hype's there, we can look up. Don't know what I'm doing either. Kuratowski's theorem. How do you pronounce that? Maybe you should just look up how to pronounce his name. Maybe that would be the most productive thing to do. do with planar graphs. I'm guessing you know what planar graphs are. You might not. I'm not going to go into what a graph is. I could go into what a planar graph is, but I don't know if I can. Theorem. What is it? Oh, we can have sick music as I find out. Yo. So that a finite graph G is planar if it is not possible to subdivide the edges of K5 or K33. Finite graph K is not possible to subdivide the... It's planar if it is not possible to subdivide the edges of K5 K33. We add additional edges to form a graph isomorphic to G. Additional edges and vertices to form a graph isometric to G. I don't get isometric graphs. Never did, never will. This isn't inspiring, this is frustrating. This is what happens when you start to study. You're like, yo, it'll be interesting and fun, and then it's like, oh. Not fun. Oh my goodness, why is isometric graphs so complex? But clearly it's more than that, because it's saying the graph can be isometric and add additional... Pain. I guess the other thing is I could do simplex algorithm quickly, but that's kind of dull as well. Yeah, okay. Sick, inspiring end bit. Let's just make that loud and then... I wish I could fade it out slowly, but I can't, so... just ends abruptly. Okay, bye.